Hello, what's up guys, welcome to new video. This video will introduce the register transfer level, RTL, design and show Verilog code and test bench for the question of the RTL. What is RTL? Larger designs are built by interconnecting the smaller modules, components at the level of registers, multiplexers, decoders, adders, etc. In RTL design, a digital system is partitioned into two main units, which are: Control Unit, CU, is a circuit that generates the signals to control the process or operation of the circuit in the DU. Data Path Unit, DU, is comprised of registers, buses, and processing and computing units. Duku module is used to connect these two main unit. That all for the introduction of RTL. Let's move to solve the question. This is the question that need to be solved. With a resource allocation constrained to one multiplier/divider, one subtractor, and one shift to perform the multiplication by 2, derive the Verilog design of the FDA that computes the equation equals 2x divided by 3 minus y divided by 3x power 2. Data flow graph, DFG, and single assignment algorithm need to be drawn to show a simple view on how to solve the problem. The schedule and RTL code show the detail of the resources that being used and the number of state. There are 5 state which from state 0 until state 4. State 0. Substitute variable x into register 1. Substitute variable x into register 2. State 1. Substitute result, register 1 multiply with register 2, into register 2. Substitute variable y into register 1. State 2. Substitute result, register 1 divide by register 2, into register 1. Substitute variable, x shift by 1, into register 2. State 3. Substitute result, register 2 minus with register 1, into register 1. Substitute constant 3 into register 2. State 4. Substitute result, register 1 divide by register 2, into register 3. All the process has been done and final result for equation C will show in register 3. C done equal to 1 show that the process is done. Register transfer level, control sequence, RTLCS, table need to prepare for the CU declaration. Manual calculation have been done also to compare with the result that produce from the test bench. Okay, let's move to the coding. First, do the DU first. Reset, clock, 8-bit X, 8-bit Y and 7-bit CV as input while 8-bit R1, 8-bit R2 and 8-bit R3 as output reg because always block been used. Reg for 8-bit divide output, multiplication output and subtraction output also been declared. Other than that, wire for selector LD1, LD2, LD3 and 2-bit selector for selector R1 and selector R2 also been declared. Assign all the selectors accordingly. The condition for the R1, R2 and R3 also been declared by using if statement and case statement accordingly in always block which will trigger when positive edge for clock and negative edge for reset. Non-blocking block been used for the declaration of the condition in R1, R2 and R3. Divider, multiple and subtractor also been code in always block. That all for DU, let write coding for CU. Reset, clock is input while 7-bit CV, C done in 3-bit state is output reg because always block been used. Reg for 3-bit next state and parameter for the state been declare. In the first always block, if the reset is 1 then the state is S0, else the state is next state. In the second always block, the condition has been declared in the case statement according to the register transfer level, control sequence, RTLCS's table. That all for CU, let write coding for DU-CU. Before write command for the DU-CU, the file DU and CU need to import. The file for DU and CU need to be import for the coding DU-CU. Reset, clock, 8-bit X and 8-bit Y as input while C done, 8-bit R1, 8-bit R2, 8-bit R2 and 3-bit state as output. Declare 7-bit CV as wire. The Verilog code style for the DU-CU is the positional port connection syntax, which the input and output been declared according to the position of the DU and CU. Input in the test bench will become reg while output will become reg. The test bench also monitor the inputs reset, clock, X and Y and output are 1, are 2 or 3, done in state. Set the clock equal to 0 in initial block. The clock will be in negative for 10ns and in positive for 10ns. The inputs have been changed according to time delay that been coded. That all for the Verilog code and the test bench. Let's move to the Quartus to run the prepared command. The result show the same answer with manual calculation result that shown early. Okay, that all for this video. Stay tuned to next video.